In this video, we are going to talk about another concept known as the Pascal's triangle. Now, Pascal's triangle was developed by a French mathematician known as Blaise Pascal. Blaise Pascal. He developed this concept in the 17th century. He himself lived around 1623 to 1662, and he developed this concept. Now, it is known as Pascal's triangle because anytime you add two successive numbers in a row, you get the number beneath it on the next row. This is what I mean. So if I take these two successive numbers, 1 and plus 1, I get 2, the number beneath it. If I take 3 and 3, I get 6, the number beneath it. If I take 4 and 1, I get 5, the number beneath it. If I take 15 and 20, I get 35, the number beneath it. If I take 7 and 1, the number beneath it is 8, and I get that. So this is, they all describe a triangle. This is why it is known as what? Pascal's triangle. And in arranging all of them together, you realize that they are forming the shape of a triangle. So that is why it is known as Pascal's triangle. Now let's proceed. Let's use this to expand this given example. So here we have x plus y to the third power. So how do we expand it? Always what you have to do is that to get the coefficient, okay, always raise the first term to the power of the expansion. So here the first term is x, and then raise it to the power of the expansion, which is 3. Then give y 0. Here y is 0, but because any number is to the power 0 and any number to the power 0 is 1, we don't usually write. That's why they ignore it. But then 1, x is 3 and y is 0. Why is that the case? At the end of the day, when the two terms are added, when the powers of the two terms are added, they should give the power of the expansion. The power of the expansion is 3. So 3 plus 0 is 3. They shouldn't be more than or less than the power. That's the concept. Now, let's see how to get the coefficient. To get the coefficient, now, the first thing you need to do, so the first term is x to the third power. The x to the third power. What is the coefficient of the first term? The coefficient of the first term, as you can see, is 1, because we don't usually write 1 if the coefficient is 1. We don't usually write it. So you multiply that coefficient 1. So 1 times the power of the first term. Here the power of the first term is 3. Then you divide it by how many terms are we dealing with? Only 1. So here you realize that you get 3, and that 3 becomes the coefficient of the second term. This is the coefficient of the second term. Therefore, how do you get the coefficient of the third term? The same thing. Now, the coefficient of the second term is now 3. So what do? So we multiply the coefficient by the power of the first term. Here it is 2. X is to the second power. Then divide it by how many terms are we dealing with? 2. So 3 times 2 is 6, divided by 2 is 3. So that's what gives the coefficient for the third term. And now, so how do we get the coefficient for the fourth term? This is what you have to do, the same thing. So you multiply the coefficient of the third term by the exponent of the first term. Here the exponent of x, which is the first term, is 1. So times 1 over how many terms are we dealing with here? Is 3. So you realize that you get 1. That is why we have 1. That's why we have 1 over here. That's why we have 1 in front of this y. That is why the y to the third power has 1 exponent. Now let's talk about the powers. Anytime the first term decreases its power, the second term will increase its power. Very, very important. So here in the first term, x was to the power 3 and y was 0. And then in the next term, x decreased and it became 2, and then y became 1. That's what we have. And then in the third term, x also decreased, x became 1, and then y became 2. That's what we have over here. And then in the last term, as we did, x became 0 and y became 3. That's what we have. That's the second property. Now the third property, this is how you expand any binomial. And then the third property is that always you realize that they are symmetric. If I say they are symmetric, what I mean is that look at the coefficient of the first term. and the coefficient of the last term are always the same. The coefficient of the term after the first term and the coefficient of the term before the last term is also the same. It means they are symmetric. That is how all binomials are. So put this in place. So anytime you are expanding a binomial and then they are symmetric, the number, the term after the first term, and then the term before the last term will always be the same. It means they are symmetric. And now the next one that we need to understand about this is that we always have to understand that anytime you have this concept, this binomial, it is very useful that you know that always you have to or add to 3. So if you realize that in this term the power x plus y will give 3, and then here to x, the third term, to you realize that this whole one will give 3. This whole one will give will give 3. So basically, that is how the powers will always add to give the power of the expansion. It will not be less or it will not be more. That is how we use Pascal's triangle to expand any binomial, and this is how the formula for binomial theorem was derived. So understand, let's move to the next video and then practice other concepts in binomial theorem. Thanks for watching, and let's meet in the next video. Bye.